So we're going to test our differential pair, not the full comparator, but just the differential pair. So I soldered everything together. I got a power supply, an LED that says I've got a power supply, two ALD 1103s. I did a lot of wiring on the back, so you can't really tell what I've done. But like always, I've done a plan for my layout. And what I've done is used a voltage divider right here to come up with 2.5 volts, so that's going to be our trip point. So for this part, I'm doing a sine wave that goes from 0 to 5 volts. That's the yellow, and the output is the green, and you can see a kind of comparator-like behavior already. But if we go to the XY setting and then click on display infinity persist, all right, you can see essentially we're tripping right around 2.5 volts. You can measure this, you can save it as an Excel file and plot it out. Now, one thing I wanted to do is compare the gain. So there's a quick way to do that. We'll go back to the time mode. We're at 10 hertz. We're going from 0 to 5 volts in half the time, half the period. So ultimately, we're going to have a scale factor of 100 when we take the derivative. So if I put on math, and it might be a little bit hard to see, all right, that the scale is a kilovolt per division, and that's this blue or purple. And if I divide that by 100, I'm getting like a gain of 30. But that's not exactly what we're getting, and in simulation, the reason why they're not matching is the time step isn't accurate enough. So if we kind of zoom in on the time, we can get a better idea of what's going on. And I want to just offset that. So I'm getting about 5, let's maybe call it 8,000. Divide that by 100, that's 80, which is about what we were getting. Sometimes it does depend on how much I zoom in on the gain, but that's pretty close to what the predicted gain was of just the differential pair. If you want to see something, I'll give you a bonus, is that if you bump up the frequency, we should start to see some hysteresis. Oops.